Welcome to day 4 notes. I'm going to have you pause the video and try to work through this warm-up. If you get stuck, that is okay. This is a very challenging problem to start off with. Then you can unpause the video and see how it's done. So for this, we want to prove that angle 1 is congruent to angle 7, and we are given that angle 2 is congruent to angle 6. So we start with our statements on the left and our reasons on the right. So the first statement we have, number 1, is that angle 2 is congruent to angle 6. That is what we are given. We are trying to prove angle 1 is congruent to angle 7, so we are not given that. So there's a few different ways you can go about doing this, but generally speaking, when in doubt, if you have two things are congruent, say their measurements are equal. It may or may not be necessary. All right, so measurement of angle 2 is equal to measurement of angle 6. That is just the definition of congruent. Now, if I'm looking at these, angle 1 and angle 7, I'm trying to find those. So I can't really mark that picture, but I need to keep those two angles in mind. What I do know is that these angles are congruent. And if I had left the angle 1 and angle 7 measurement, I could see I'm trying to look at linear pairs. So what I could do for step 3 is say that angle 1 and angle 2, angle 6 and angle 7 are linear pairs. Alright, so this is one where I'm not going to be too picky. This is going to be the definition of linear pairs. What I mean by I'm not going to be too picky is that if you can switch around definition of linear pairs and the linear pair postulate, I'm not going to be too offended because they're basically both going to be used in succession each time. Because now in step 4 I can say measurement of angle 1 plus measurement of angle 2 equals 180. The measurement of angle 6 plus the measurement of angle 7 equals 180. And that's my linear pair postulate. Okay, the definition says these things are a linear pair. The postulate says that the linear pairs add up to 180 degrees. So if two things are equal to the same thing, then they are going to be equal to each other. So step 5, measurement of angle 1 plus measurement of angle 2 equals measurement of angle 6 plus measurement of angle 7. Okay, you could use the substitution property, but the transitive property is going to be a better choice here. And now this is where we use what we found in step 2. You can replace either measurement of angle 2 or measurement of angle 6, one or the other. Ultimately, it does not matter. You'll have measurement of angle 1 plus measurement of angle 6 equals measurement of angle 6 plus measurement of angle 7. That one has to be the substitution. And now we are going to solve algebraically to get measurement of angle 1 equals measurement of angle 7 by subtracting. Okay, you could write subtracting, subtract, subtraction, they all mean the same thing. And if two things have equal measurement, that means that they are congruent. If they are congruent, I no longer have to put the m in front. Get angle 1 is congruent to angle 7. Again, that's our definition of congruent. That was what I wanted to prove. That's my last step in my statements. So now I am officially done with that problem. Okay, so for this, two angles form a linear pair. The measure of one angle is 4 times the measure of the other. Find the measure of each angle. Draw a picture. They form a linear pair, so draw a line. Draw a ray coming off of it somewhere. I don't really even have to label. Don't have to label the angles. That's perfectly okay. I know that one angle is bigger than the other, and the other angle is what I'm going to put as the small angle as x degrees. I'm doing this because it says that the measure of one angle is 4 times the measure of the other. The other is always going to be a single variable, so this means this other one is 4x degrees. Alright, so if I want to find the measure of each angle, sorry about that. Find the measure of each angle. I've got 4x plus x equals 180 degrees. I know this because they are a linear pair. So that gives me 5x equals 180. Divide both sides by 5. I've got x equals, that would be, well, 5 goes into 18 3 times, then it goes into 36 times. So x equals 36, not 36 degrees. So that tells me that one angle is 36 and the other angle is 4 times 36, which 6 times 4 is 24, 4 times 3 is 12, plus 2 is 4, so I've got 144. Those two angle measurements should add up to be 180 degrees, and they do. So the angles have measurements of 144 degrees and 36 degrees. Notice I didn't say this is 36 degrees because the angle was x degrees. I don't want 36 degrees. So my final answer would be that right there. So for this next one, it says describe and correct the error made in finding the value of x. So when we look at these, we want to kind of basically do the problem ourselves and see if our steps are different. So I can look at these and say, hey, these are a linear pair. So that means if they are added together, those two angles added together, instead of being 90, should be 180. So this is the error, okay? The fact that it equals 90 degrees. So what I should have is 10x minus 20 plus 10x equals 180. Anytime the problem says describe and correct the error, what I don't want you to do is say, oh, this answer is wrong. Of course it's wrong. I'm telling you it's wrong. That's not what the mistake was. The mistake was that we set this problem up incorrectly. Now when we solve, we've got 20x minus 20 equals 180. So 20x equals 200. So x equals 10. Okay, if you plug these numbers in, 100, 10 times 10 is 100, minus 20 is 80 degrees. 10 times 10 is 100 degrees. 100 plus 80 equals 180, so I know that my answer is correct. Now we want to prove angle ABF and angle DBC are complementary. Okay, remember when we're trying to find complementary, what does that mean? It means they're going to add up to be 90 degrees, so I know I'm going to have to do something with angle measurements. We're given a whole bunch of different things. So I need my statements and my reasons. I'm just going to put an S and an R because I'm lazy right now, I guess. So step one is what we are given. We're given that ray BD bisects angle EBC. Ray BE bisects angle FBD. And that angle EBC is a right angle. Okay, so I can mark that right angle in my picture right away. But I need to be a little bit more specific. I need to define each of these things. So step two, I'm going to start with bisecting an angle. What does it mean to bisect an angle? Well, it means it's going to cut angle EBC in half for that first one. So that tells me that angle EBD is congruent to angle DBC. It tells me that when I'm looking at ray BE, that we get FBE is congruent to angle EBD. I can do both of those at the same time because they are the definition of an angle bisector. So when we have a vocab term in our given, or a vocab term in our statement, we use the definition of the vocab term. The vocab term here was bisect, so we have to be careful. You cannot just say definition of bisector. You have to tell me what kind of thing is being bisected. Is it a segment or an angle? So we're bisecting an angle, so we need definition of an angle bisector. So what that tells us is that this is congruent to this, and then we also know that this is congruent to that. Now, the fact that I put this angle twice tells me that I'm going to be able to put those two things together, but I have to do a little bit more work. So you could jump to that right away. I'm going to jump to this being a right angle and use that definition as well. So the measurement of angle EBC is 90. Yeah, that's the definition of a right angle. The reason why I need to do that is because I need to find an angle degree. So I need to be able to use degrees at some point. If that's given to me, it's probably going to be important. So what I'm going to do next is, I saw that these two things are the same. So then I can put, for step 4, that angle DBC is congruent to angle FBE. That is my transitive property. At this point, you cannot do the substitution. I can't say I'm substituting this in to get this statement, because you cannot do substitution if you have a congruent sign. So you got to make sure you're using transitive. Now, DBC is one of the angles I was looking at, but FBE was not. So maybe I might feel like I'm not getting everywhere that I need to, but this is going to be important because step 5, I'm writing kind of big, so I'm going to kind of scroll down there. I apologize. I might go over to the side here, but angle DBC is going to be, well, if I've got a bunch of congruent signs, right? So I know these are congruent, and I know those are congruent, so I can say that measurement of angle EBD equals the measurement of angle DBC equals the measurement of angle FBE. That's our definition of congruent. I've got all those things are congruent to each other, so I've got that their measurements are equal. And now what's going to be nice is that I've got a nice straight angle here, and ABF is the only angle that I don't know. I know what using different color, sorry about that. I know that this is 90 degrees, so I'm going to be able to figure out what each of those are, which means I know what that is, so I'll be able to find out what that is. So step 6, I know that the measurement of angle EBD plus the measurement of angle DBC equals 90, right? What I should actually say before 90 is that this equals the measurement of angle, that's going to be EBC. It's our angle addition postulate. This is me being extremely thorough and precise. You have to use your angle addition postulate before you can plug things in. Okay, I know what measurement of angle EBC is, and I know that angle DBC is the same thing as angle EBD. So for step 7, I can say the measurement of angle EBD plus the measurement of angle EBD equals 90 by substitution. And then I'm going to continue up over here just so I don't go into that next problem at all. So I'm going to continue statements and reasons. In statement 8, I would say 2 times the measurement of angle EBD equals the measurement of angle EBC, which is 90. That was simplifying. And then step 9, measurement of angle EBD equals 45. I got that by dividing. Now I know this is getting really long. There are problems where there are a lot of steps, but because you have to be very specific. If you were just solving this and I said, figure out how big angle ABF is, you'd be able to do these problems. You have to go through all these steps, but you won't be writing them down. So the fact that we're writing them down is what makes these problems so much longer. Now, I figured out that this is 45. You could go through this entire problem and maybe not figure out what the actual degree measurement is if you did it another way. One thing that's really nice about proofs is that there's more than one way to do a problem. For some people, that makes them more challenging because they just want to know what is the right way. There's not only one right way. So I'm going to say step 10, measurement of angle ABF plus measurement of angle FBE plus measurement of angle EBD plus measurement of angle DBC equals measurement of angle ABC. This is another linear pair, or another angle addition postulate. If you wanted to, you could have lumped this part into step 5 or step 6 there, but we would have not used that information all at once. So sometimes if you lump things in to one step, it makes your proof look shorter because you have less steps, even though you did the same amount of work. All right, but now I know what most of those angle measurements are. So for step 11, I can say the measurement of angle ABF plus 45 plus 45 plus 45. Now, we know what those angle measurements were. That's how we get these 45s. Equals 180 because ABC is a straight angle. That is substitute. Now, if you subtract, you don't even have to worry about combining those 45s all at once. Helps if you put all the letters in the right order. I can just say subtract, and this is where I subtracted 45 3 different times. But I didn't need to find out what those angles were. I needed to figure out that they were complementary. But I figured out that both angles are 45 degrees. So I can tell me that angle ABF and angle DBC are complementary, put and comp, by the definition of complementary. So this was a proof that I did in 13 steps. You might be able to find a way that is a little bit shorter. The parts that people miss are the ones where they feel like they're not important. Things like defining a right angle, that gives you the 90. Okay? You've got to say things like that. I know you know that they're 90, but you've got to write it down. That's something that sometimes I even forget to do because it just seems so minor. But if we want to have a fully rigorous proof, we need to have a perfectly valid reason for each and every step. So for this next one, we want to prove that measurement of angle AHC is 90 degrees. So we're going to start with our statements and our reasons again. Number 1, we are given that HC, ray HC, bisects angle BHD. The measurement of angle GHF equals 80. The measurement of angle FHE equals 50. Free points right there. First statement, first reason are always free points. Now go mark your picture. Measurement of angle GHF is 80 degrees. Measurement of angle FHE is 50 degrees. All right. Step 2, we had a vocab term, so I want to use the definition of that vocab term. Okay, I can't just say bisect, so definition of angle bisector, because that's what's happening. So HC bisects to make those two angles. So it tells me that angle BHC is congruent to angle CHD. All right. Now I want to get to angle AHC, but I only just found out something about part of that angle. All right. I can have two things in this next step that might not really seem like I'm getting all of this angle, but I'm getting pieces of the information. So I know that angle GHF is congruent to angle BHD, and I know that angle AHB is congruent to angle FHE. And this is true because vertical angles are congruent. Okay? I have that X showing up right there, so I've got, I'll do this in blue. I've got this angle is congruent to this entire angle. And then in green, I've got that angle, and it's congruent to that angle. So that's going to be helpful. I've got a little bit more to do though. So what that tells me is, step 4, I've got all of these congruencies. I can throw in their angle measurements. I can do all of them at once. So measurement of angle BHC equals the measurement of angle CHD. Measurement of angle GHF equals the measurement of angle BHD. Measurement of angle AHB is congruent measurement of angle FHE. That's the definition of congruent. All right, now I know what some of these values are. I don't know what that first set is yet, but angle GHF I know is 80. So that tells me that the measurement of angle BHD equals 80 degrees. That's my transitive property or substitution since it's an equal sign. And I know these last two angles, the green ones, are going to be the measurement of angle AHB equals 50 degrees. Again, that's our transitive, or you could use substitution. Now, what I just found is that this is 50 degrees. We know that for sure. I don't know what this is yet, but I need to figure out what that is if I want to figure out what angle AHC is. So for step 6, I'm going to do angle BHC plus, I should say the measurement, sorry about that, measurement of angle CHD equals the measurement of angle BHD. That's our angle addition postulate. And I know that those two angles are the same, so I can say that measurement of angle BHC plus measurement of angle BHC equals, and we know the measurement of angle BHD is 80 degrees by our substitution. Now if I simplify, I've got 2 times the measurement of angle BHC equals 80. So that tells me that the measurement of angle BHC equals 40 by division. So divide. Now, I did something that was going to save us a little bit of time. So I made this BHC and BHC here in step 7. You could have had that be CHD and CHD. But what is nice about picking BHC is that's the little piece of the angle that I need to know. I'm basically saving myself one more step or 2 more steps. So I know that that's 40. So that tells me that if I do step 10, I can say that the measurement of angle AHB plus the measurement of angle BHC equals the measurement of angle AHC. I can say that's my angle addition postulate again. Plug in those values. 50 plus 40 equals the measurement of angle AHC. Oops. Okay, that's my substitution. 90 equals the measurement of angle AHC. If I simplify, and most of the time I'll be done here and I'll say that's good, but technically we have one more step because we were actually wanting to prove measurement of angle AHC equals 90, not that measurement of angle, or not that 90 equals the measurement of angle AHC. It's a little bit of semantics. So if you remember our transitive property, our commutative property, and our associative properties, and our symmetric properties, and all that fun stuff. Symmetric property is what we were using here. We're just switching the order. If you stop at 12, I'm perfectly okay with that. Now, this next one is going to go, I think, a lot faster than that last one. Okay, so number one, we are given angle 1 is congruent to angle 3. Measurement of angle 2 equals 60. That's given to us. So we want to prove that all angles are congruent. So if we want to prove they're all congruent, we've got to figure out probably that they're all the same degree measurement. So I know that I could just use definition of congruent right away, but I know I'm going to be doing that multiple times, so I'm just going to go to step 2 and say that angle 1 is congruent to angle 4, angle 2 is congruent to angle 5, angle 3 is congruent to angle 6, because vertical angles are congruent. And now this is what I'm going to say, that the measurement of angle 1 equals the measurement of angle 3 from the first step. Measurement of angle 1 is equal to the measurement of angle 4. Measurement of angle 2 equals measurement of angle 5. Measurement of angle 3 equals measurement of angle 6. That's my definition of congruent. So I've shown that a lot of these things are the same. I showed that measurement of angle 1 and measurement of angle 3 and 4 are all the same. So if I can figure out some of the rest of the stuff, it's going to make my life a little bit easier. I know that the measurement of angle 2 is 60. So that's also going to be helpful, because that means I'm going to be able to know what this one is, and that's 60. I haven't shown that in the proof yet itself, but I don't really need to. All right? So I just need to get that these angles all add up to be that same thing. So I know that the measurement of angle 1, 2, and 3 has to make a straight line right there. So if I look at angle 1 plus the measurement of angle 2 plus the measurement of angle 3 equaling 180. And I'm kind of letting you cheat a little bit, and I'll just let you say angle addition postulate. Okay, angle addition postulate would tell us that this angle adds up to that straight angle, which we know is 180 degrees. So I'm kind of having a little bit of semantics that I'm okay with here. So I know by substitution that I've got measurement of angle 1 plus 60 plus measurement of angle 1 equals 180. Okay, if I simplify, I could say 2 times the measurement of angle 1 plus 60 equals 180. So 2 times measurement of angle 1 equals 120 by subtraction. So step 8, I've got measurement of angle 1 equals 60 degrees by division. All right, so right now I know in this picture that I've got 60 degrees here, 60 there. I haven't shown it yet necessarily, but I know that one's 60, I know that one's 60. Vertical angles are 60, so I've got something that I can say is 60 for everything. So step 9 is going to be that measurement of angle 1 equals the measurement of angle 2 equals the measurement of angle 3 equals the measurement of angle 4 equals the measurement of angle 5 equals the measurement of angle 6. That is my transitive property. All right. Now, I kind of put a whole big transitive property together, because what I already knew was this stuff. Okay. But what I just showed was that measurement of angle 1 was 60. So measurement of angle 1 equals 60 equaled the measurement of angle 2, which equaled the measurement of angle 5, right? But I also knew that these angles 1 and 3 were the same, and 3 was the same as 6. That's how I was able to get everything equal. But what I needed to show is that all angles are congruent. So the last one is angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4, congruent to angle 5, congruent to angle 6, with the definition of congruent. That's the last proof for the notes. So these proofs, they were very long. Not every proof is this long. There are some that are very, very short, and then some that are even longer. What's nice is that it's kind of up to you how long they are. If you can find a nice, short, easy way, that's awesome. If you can't, that's totally fine. As long as you are showing completely accurate math, I am okay with however you solve it. All right? Now here's the homework that goes along with it. Make sure you take care of that as well. Hope everybody has a great day.